Guys, today we are going to talk about Cloud Build, which is a serverless service provided by Google, and it is also a managed like continuous integration and continuous delivery platform offered by Google Cloud. So basically, we use Cloud Build as a service to execute our build on Google Cloud. So like you want to create an image or you can want to deploy something, so we can use Cloud Build to build all that artifacts for us. And Cloud Build can import our source code like from variety of repositories, like you can put it into cloud storage or we can get from GitHub or cloud source repositories. And it can also produce artifacts such as Docker containers or Java archives, or like if you are using Python or anything like Node.js, so it can develop, like produce artifacts for them also. Also, our like artifacts can include like our compiled code, configuration files, scripts, libraries, and like our virtual machine images, and many more things we can include. And also, when we want to use that cloud build, so basically we have to create a build config file. So in that we give instructions to cloud builds on what task to perform, and like we can configure Cloud Build to fetch dependencies, run unit tests, and run integration tests, create artifacts with build tools like Docker, Maven, and like Gradle. And also, Cloud Build executes our build as a series of steps, whether each step will run inside a Docker container. So, like if you have created 5 steps, so each step will run by a series like one by one. But we can use some more option, but we can see later on that part. And each build will run in a separate container. So once when build step is completed, that container will be deleted, and all the data will be passed to another container, the second container, and like that our build step get completed. And we one more thing we have to remember, that when we run the cloud build, it will uses a kind of VM only in which our like all that build steps will run, and it uses shared pool of VMs. So like it will take a free VM, it will run our build and delete. Once the build has been completed, it will just delete all the data from that machine, so that no one can access your data. Even not Google Cloud cannot access your data once your build has been completed. But so now we have some on, like we can write our own build steps. So that build steps can be or even we can use that build step provided by Google Cloud, or like there's some one more community we can use, Cloud Build community, to use their build steps. So basically how our builds works. So first of all, we have to prepare our application code or source code. Like you have an application running, so just you have to prepare a source code like Docker file or anything which you are using. After that, we have to create this cloud build YAML file. It is, you have to remember, this is very important file. So when you want to use cloud build, you will use this cloud build.yaml. If you are using YAML, if you are in JSON, so you can use cloud build.json format file. So we have to create this config file in which we have to write our all the configuration, like this is the config file example. We have to provide all the steps. After that, we have to submit this build to Cloud Build. And when Cloud Build executes our build on the build config we have provided, like this, we have what we have provided, it will just execute our build. And if applicable, any build artifacts are pushed to the artifact registry. Like if we have any like Docker image has been created or some Java archive has been created, it will be pushed to artifact registry. And one thing we have to notice, that like Cloud Build allow us to build a Docker image using a Docker file also. So we don't need to write this all thing. We can just use a Docker file and just submit the build, and the Cloud Build will create a Docker image for us. So let's see what these steps are. So first of all, when we write a Cloud Build file, we have to start with this first one, the steps. In this, we write multiple steps you want to write, and the first step is name. So here we are using cloud builders. So what is name? Name, it is an image which we want to use. It is a container inside which our configuration will run. So first of all, we are asking Cloud Build to use this image. Cloud Builders GCIRIO, it is a repository, and we are using Cloud Builders Docker image. So we will check out Cloud Builders later on, because that is a kind of advanced. So first we will just going basic over in this video. So we are asking Cloud Build that we want to use Docker image. So once we are got into the Docker image, then Docker image means we want to run Docker container with this image. So once we are into Docker container, we will run this command. So Docker build, you know, must know about containers. If you don't know, you just check out some courses on the YouTube also. So we are just asking to create this image like Docker build hyphen T, and this is our repository name. This is our project ID. This is our like folder name. On this we are just tagging this, and after that we are giving an option auto map substitutions. It is true. So it what it is substitutions means, instead it will automatically take the project ID from our cloud shell. We don't have to provide here. You can see the project ID. So there are many auto map substitutions. We have to like check it out on the like documentation page. After that, another step is like images. Whenever you use this option images, it automatically push your image to the artifact registry. So you have to remember that this is a very important thing. If you want to use this, you have used this images part, it will push your image to artifact registry. Even we can use Docker push command also if you want to, but both can be used. And what we are using, just giving that image name which we have created in above step. So we will check it this out examples also. After that, there are some private pools also. Suppose you don't want to use shared pools of VM which a cloud will provide. There's some security issue, and like you want like your build always be created in like full security. No one can access your data, and you want your own VM. So we can create private pools for that. So it is a like private and dedicated pools of like workers that provide greater customization for the build environment. And even we can access resource in a private environment. Suppose before building your like running your cloud building. So suppose before running your build, you want to access some private resources in your GCP, like you want to access some VM configuration or cloud storage, something like that. You want to just access, so you can use private pools. If you use default pools, or we can say we don't have access to our private resources. As you can see here, this is a cloud build. This is our service producer network in which our cloud build will run. In this only our VM will be created in which our cloud build will run. And here we are using with the help of network peering, we are accessing our customer project like private resources. So we will do this demo and we will check it out. So basically, if you have heard of private service connection, that we have to use here. After that, private host pools are always hosted in a Google owned service producer network. So it is a service producer network, means that Google owned network where the private pool are hosted, and it comes with internal IP. So for our build to access resource in private network, so like for this build to access our resources in the private network, we create a VPC peering connection between our VPC network and the service producer network. So we will create a VPC pairing between both our networks. So this is Google network in which our private pool has been created, and in which our cloud build is running our build steps. So from here we want to access some like our VM or our cloud storage. So we have to create a peering. You know, two different networks cannot communicate. That's why. So there are some differences between default pool and private pool. Like both are fully managed. You don't have to do anything. Pay per build minute, auto scaling like scale to zero, access to public internet, in it is allowed. In a private pool you can configure, like sometimes in your private pool you don't want to configure the internet, like you want it to be private, no one can access over the internet. But if you want like some files which will fetch over the internet, you can allow private pool with the internet. We can peer into a VPC shared VPC. In this default pool this is not allowed because it is a default, and it is a private pool, that's why it is allowed. We can use service controls also. Static internal IP ranges also it is allowed in private pool. We can ability to disable public IP. Yes, we can enable disable. You can see concurrent builds 30 100 plus machine type. It provides 15 machine types. Here only 5 machine types are there. Regions, it is global and supported regions. It has supported regions only, like it is not supported in all regions. And the region in which build is run, the build is run in the region specified in the cloud build submit command, or the build is run in the region where you create the private pool. So like if you have created a private pool in that Delhi location, the build will also run in the Delhi location. So let's start our demo and see what the options we have. So here I'm in my cloud build console. So first of all, we will try with basically Docker file. So here I'm in my Cloud Shell. So basically, let me go into my folder where I've created some scripts. So here I have a Docker file and I have a kickstart.sh. So let me get the Docker file for you. So basically, we are using this Alpine image and we are just copying this kickstart.sh into our directory workspace directory, and then we are running this command. So like this quick start.sh is nothing, just it will give it the time. So if we click start.sh, it will just tell the hello world, the time is this and that. So first of all, for use this we have to create a artifact registry. So we are going to create an artifact registry. We can create via command line also, even we can create with the help of here also. So first we have to go to artifact registry and just click on create repository, and we have to give it a name. So we just use this name also, use stack docker repo. And after that the format, so there's multiple formats which one we can use, like Maven, npm, python, depends upon that your application type. So I'm going with the docker because it is my docker. It is more standard reason. Let's choose us west 2. You can choose according to yourself. And encryption is Google managed, and dry run, like it will not use the artifacts. We will come upon this later on, that what is artifact history. Basically it stores all the artifacts, but we will work on it on that depth or advance how it works. So just create our artifact registry so that it can store our image. So our registry has been created. So if we go inside that, so we can see like it is start with us west hyphen docker dot package dot dev. This is my project name, this is my folder name, or we can say like this repo name. So I will run this command gcloud build submit. So I'm submitting this build to the cloud build, and I'm using this tag, and I'm using this us west. This is the my our repository, that our repos which has we have created in artifact registry. We'll update, just update my project id, and it looks good. So let's submit this. So we can see that it is success. So it runs our command. Like from here we can say step 1 from Alpine, it just pull the image from Alpine. This is imaged. After that it copy this is the quickstart.sh, and then it runs that command. And we can even see if we go to our artifact registry, and if we refresh it, we will see an image here. So you can see we just got this image quick start image. And so this is our this is our name, quick start image, and this is our tag which we have applied to it, tag 1. So this we have done via docker file. Now let's try to do this via cloud build.yaml. So we will use this command. So basically what we are doing here, as you can see, this is our steps. The first step is we are going to use the docker image. So this is the cloud builder and we are asking you the docker image. And after that we are giving a script. In the script we are saying to uh, build this image again. So docker build hyphen d us best docker. This is project id will automatically be changed, and this is our repo which we have already created, and this is our image name, and let's give tag 2. And we are given dot, so it will find the docker file and all the things from our source directory where we run this command. And after that we will giving this one images. So it will, once that image will create it, it will just push into our artifact registry. So just copy this and go to here, and same folder where these all the files are there, we will create one more file. We call this cloud build.yaml, and just we paste that commands. After that we have to just run this command gcloud build submit. We have to select the region, and in the config we have to select that cloud build.yaml. We will just run this command. Let's wait. We even can see that this is do the same thing which we have done on the docker file. And if we go to artifact registry now again and just refresh this once again, we will see now we have a tag 2 also. Then the same thing. So we have just checked with the help of cloud build. We can use docker file, or you can even use cloud build.yaml. So if you go to cloud build and click on history also, we can see our builds which we have ran. Even if you click any one of these, you can click on that. This is our builds, and inside it we will get all the information like build log, it has done, like it is fetching, copying, all that things. So this is our steps, which is it ran from Alpine. It has then copied this image, this is SS file, then this, and then it is pushing this. We can see all that with the in the cloud build also. So that's the very basic demo. We can even you can use this to deploy to like Cloud Run also. So like if you want to deploy Cloud Run, we can use these steps. So we are now using one more image which is in which we want to G-Cloud, in which G-Cloud is already installed. So it if G-Cloud installed, but means it has all the commands, like all the G Cloud Shell commands. So we are running a script G-Cloud run deploy Cloud Run service. We are giving that image name. This image, which is a hello image, we are asking to use hello. You know, it use a basic image hello, and we are giving a region platform which is managed and allow unauthenticated so it means anyone can use it. So let's run this also. So let's go here, copy these steps, and let's create a one more directory. Make directory cloud run, cd cloud run, and we will create a cloud build.yml here also. Just paste this command. So we are using the G-Cloud and running this command. And before running this, we have to do one thing. Go to your settings, and you will find here this all the things. Whether as of now you can see the Cloud Run is disabled, so we cannot access Cloud Run with this our service account. First of all, we have to enable it. So once it is like we have to give access. Now it is enabled, so now we can run this. So again, we will go back to our and just run this command, the cloud build submit, and we can use any region you want and just click on enter. So we can see that is success now. So it means with the help of that command we have just created a cloud run service. So let's go to cloud run, and we can see it is created also. And if you go inside that cloud run service and click on this, let's see, so we can see it is running also. So you can see we even can deploy with cloud run also, sorry, cloud build. You don't have to do manually anything, you just have to do some create the scripts and it will automatically deploy to even we can deploy to GKE app engine or anything you want to, like you want to use. So that's the power of this. We can see like the cloud build. Even we can use repository, so even once you commit anything, we will come out on triggers later on this, not right now. It is a very basic thing we are going to use, but we can use setup triggers also. So last part we can do is just let's set up private pools. As I've already talked about, it is like a kind of isolated thing. So let's click on create, give it a name. So we can give a name test. So we can choose a region like northeast. After that, we have multiple machine types. So I've told you we have 15 machine types. So you can choose any one of these. So like I will choose E2 medium, and disk size. If you don't give any disk size, it will take 100 GB by default. So we can leave. So first of all, we have two types of network, default and private. With the help of default, it is a private pool only, but in default we cannot access our private resources. But it like the machine in which your builds are run, it is a private only. But with the help of private network, we can even access our resources in private network. Like you want to access some VM IP or anything, we can use this also. So first of all, let's create default one. We can assign external IP also if you want to access something from internet, and just click on create. So sometimes it creates, sometimes it doesn't, because of the resources. There's some issue of resources also. Let's see whether it created or not. So for me it has been created. It is a default pool, as we can see. Even we can edit it also, like in the future if you don't want this external IP, you can remove it, or even in the future you just need a higher machine, so you can run your like you have a bed which takes so much of memory and all that, you can even increase that machine type also. So this is specific for you only, and this is private, so no one another can use this. Like we have checked, like in previous, it is a kind of shared pool, but it is isolated also, but it is give more security to you. Like if there's some security issues in your organization and they want that specific machines only run your build, so you can use this private pools. So before creating a private pool which from which we can access our private resources also, few things we have to take care. First of all, service networking API must be enabled uh, in your project. So first of all, click on service network API. I have already enabled, but it is not enabled, please enable this. You can just enable here from this option of enable. After that, go to your VM, sorry, in your load in your network in which you want to use, and go to private service connection. And you can click on allocate a range, allocate IP range. Like you can give cloud build range, and after that you can provide your own IP address or you can use automatic one. Let's use automatic, and we have to give a prefix length. So let's give /24. Oh, sorry, not /24, just 24, and click on allocate. So Google will allocate IP range for us. You can use your range also. So once, so it is has allocated this one. So now go to private connection to services. So we have to create a connection here. So select your IP range here, click on OK and click on connect. So what will happen? It will just create a peering between our network, LB network, and this network within the Google network where this IP range has been created. Until you create a private network between both of your networks, you cannot access your like VMs or anything or any private resources. So this part you have to just so my private connection has been created, as you can see. If we even click on VPC network peering, we can see that also. You can see a peering has been created between my network and that peer network of service networking, which is at the Google end. So this step has been done. Now let's go back and create one more network pool. So let's give it name of private, and we have to choose a region. Let's choose this region. Machine type, let's go E2 medium, and this is a private network. We have to choose our network, which is our LB network. If you want, you can give your own IP range also, like you want this IP range must be used in that on your in that network. Like if you want like 192.168.4.0/24 must be used inside Google network, so that VMs created with this IP range, you can use that also. I have tried, but it gives some error as of now, like maybe because my free trial account. But if you have organization account, you can just try out and just click on create. So we can see our private network has been created, private pool has been created. It is using LP network. So now it's time to do the testing. So let's go to my CD. I have a folder private pool. That's ls. So if we do the cat cloud build.yaml, so what I am doing, I have a VM running here. So this is my VM in the LB network, and let's copy this IP 10.1.1.11.4, and we are going to ping this IP, and we are using the pool. So whenever you use a pool, you have to use this command options pool and then the pool name, otherwise it will not work. So let's edit this. So vi cloud build.yaml, and now update the IP. So we are using what we are using bash. So bash is a like image in which we want to run this command ping. So but bash is now outdated. You can use script only, like in previous command, like we use script. That will work here also. And after that we have to update this. So first of all, let's try with the test one, which is our default network and it doesn't have access to our private resources. So let's update this. Looks all good. And let's see northeast one. So update that this also. Okay, submit G cloud builds, submit. So we can see our build has been failed. So if we go back and check out what is happening, so it is pulling an image bash which has is successfully pulled. After that it is running this command ping 10.1. We can see it is packet 6 packet transmitted and all are packet lost. That's why it is failed. So even if we go here also in the build history, it will give a failed only. So here it is not update. Okay, we have used the region is our US. Our region is Northeast Area 1. So here it is. If we go inside that, we will get the same logs here also. Like it is trying to this and this, it is getting failed. So one thing we have not given any this region here because I have already told you in the slide also the build runs in the region where we have created the pool. That's why we have not provided any region here. And here the build runs in the region is specified in the G Cloud Build Submit. So I think you understand why we have not provided region here. So now let's edit it and let's use private pool which has access to our private resources. Let's see what its name. If you go to settings and click on worker pool, so its name is private. Let's update it. Private, and it's in Northeast 2. Yes, so just run this command once again, gcloud build submit, and let's wait. So we can see this. See, right now it is also pinging that our private IP. So with this is the private IP of my VM. So we can see it is able to ping and our build is also success. So we have identified that with the help of private pools and with the if we set up properly, we can access our private resources from the cloud build also. So like you want to access some cloud storage files, so you can use that or many things like cloud SQL, anything you want to access with the help of private pools, you can access. And also once you done, it will create a like one file in your like storage. You can check it that file in which it will just copy and paste all that information for. So this is our little demo. In the next demo I will talk about like how you can use secrets in this cloud build, and we will also talk about cloud builders and many more things which is provided by like cloud build. And we will also talk about setup triggers, what are triggers and how it does work and what the options we have, and many more like which images we can use and much more we will cover out. And we will also see how we can deploy to multiple things like GKE and App Engine and what are other options we have. So if you have any questions, you can just comment it out. I will try to help. Thank you.